Use Descartes' rule of signs to determine the number of possible positive, negative, and complex solutions of the equation. When we're talking about Descartes' rule of signs, we're looking at the number of switches between positive and negative. To begin with, when we look at our possible positives, we look at the switches in the original equation. So we go from a positive to a negative, that would be one switch. Back to a positive, that would be a second switch. Switch from a positive to a negative, that's a third switch. And from a negative to a positive, that's the fourth switch. So our possible positives right now are 4. When we're looking at our possible negative values, we need to plug in f of a negative x. So f of a negative x, well, negative x to the fourth is still positive, so we end up with 2x to the fourth. A negative x cubed is a negative, and if we had a negative x cubed, that would just become positive. X squared will stay the same. Negative 3x times a negative x is a positive 3x, and plus 4 remains the same. Well, the number of switches, it goes from positive, 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 positive. There's no switches. So there'd be 0 possible negative. Now looking at this in a little bit of a chart, we're looking at the number of possible positive real solutions, the number of possible negative real solutions, and the third one would be the number of imaginary, or sometimes called complex, solutions. And we always want to ensure our total. Well, there are 4 possible solutions to the equation because we are in degree 4. So I always want to make sure my total in this case is 4. Well, the possible positive solutions are 4. Well, if we had 4 possible positive solutions, that means we would have 0 negative real solutions and 0 complex solutions. When we're looking at the number of switches, if it's not 4, then we have to decrease by 2 each time. So if it wasn't 4, it could be 2, but there's still 0 possible negative solutions. But that means the number of imaginary complex solutions, since this total has to be 4, then the complex would be 2. Well, if there weren't 4 or 2, there could be 0 real solutions. There's still 0 negatives, but if it's 0 and 0, and we know the total has to be 4, that means there could be 4 possible imaginary solutions. Therefore, this chart, or if we look at it in terms of possible positive, negative imaginaries, we've got 4, 0, and 0, 2, 0, and 2, or 0, 0, and 4 for our solutions.